Okay, so today we're going to be looking at solving more complex or more complicated multi-step equations. And the focus today is going to be on questions that involve multiple skills, such as combining like terms and distributive property before even thinking about solving the equation. So let's look at example 1. We have 4x plus 3 minus x equals negative 7 plus 2 plus x. So the first thing we want to do here, like always, is separate the left side from the right side by drawing our wall, okay, down the equal sign. Next thing we want to do is scan the problem to see if we can combine any like terms. Let's look at the left side. We see we have a 4x and we see we have a negative 1x. So I can combine these. These are like terms because they both have x. So let's blend them together. If I have 4x's and then I have a negative 1x, or 4 minus 1x, that's going to give us a positive 3x. Remember to bring down the integer that we did not touch, that plus 3. Bring down your equal sign. Now let's focus on the right side. Do I have any variables or x's to combine? Now I only have one x. I'm going to go ahead and draw the 1 in there since there's no coefficient. But do I have any integers I can combine? Numbers. In fact, I do. I have a negative 7 and a positive 2. So let's go ahead and combine them. It's an integer question now. Let's use our rules. Same sign or different sign. In this case, the signs are different, which the rule states if the signs are different, we subtract and take the sign of the higher number. The 7 happens to be higher than the 2, so we take the negative this time. And now we're going to bring everything else down that we didn't use, which is just that plus 1x. So now let's refocus on the original problem here. Remember, our goal when solving equations is to get all of our variables on one side of the equal sign and all of our integers or numbers on the opposite or other side. So here we can see we have a 3x and a 1x. Remember, you cannot just combine those and get 4x. They're on opposite sides of that wall. In order to get them to be together, you need to perform the opposite or the inverse. Think of it like you're paying a toll. In order to cross this bridge or this wall, you need to pay the toll to go across, and that toll is to do the opposite. The reason we're going to choose the positive 1x in terms of moving it over is because this is the smaller variable. So the opposite of positive 1x is negative 1x. And when I do one side, I must perform the same thing on the other side. And remember, opposites always cancel each other out, or inverses, because they equal 0. Okay? So now we have 3x minus 1x, and we get 2x. Bring down the plus 3 integer that we didn't touch yet. Bring down your equal sign, and bring down a negative 5. Remember to be careful when rewriting that you carry down the negatives with it. Okay, now we have our x's all on one side. So now all that's left is to move the integers to the opposite or other side. Here, the only thing in the way of getting this 2x by itself is this plus 3. So the opposite, remember, we do the opposite to cross over the barrier to the other side. We need to pay that toll. The opposite of adding 3 is subtracting 3. And what I do to one side, I must perform the same thing on the other side to keep this equation balanced or equal. Opposite or inverses always cancel. That leaves me with 2x equals, and now we have to solve this integer question. So again, let's use our rules. Same sign or different sign here. In this case, the signs are the same, so that dictates that we need to add the two numbers and keep the sign. Same sign, add, and keep. So now we're almost there. So the last step to getting x by itself when you're solving equations and you have a coefficient is to divide. Remember, when we divide, we must divide by this exact number, the exact coefficient. If it's a positive 2, we need to divide both sides by a positive 2. We do not change the sign. So x equals, so now again we have a situation here where if you're not good with integers, multiplying and dividing them, you can use the triangle. We have a negative divided by a positive. So let's cover those up, negative and positive, and we're left with a negative. And then 8 divided by 2 is a 4. So now we have x equals negative 4 for our answer. Okay, now we're going to look at another question, and they're going to step it up a little bit, because this one involves both combining like terms and the distributive property. So let's take a look at this. Okay. Alright, so in this case, we're going to start off by drawing the wall again, separating the left side from the right side. And in this situation here, we notice that we have parentheses, so we need to actually distribute the 2 here through the parentheses. And when you do that, we're multiplying. We get 2 times 3x, and that gives us 6x. And then 2 times 1, and that gives us 2. Now we can bring this negative 1x down. Remember to put a 1 there, because we didn't touch it yet. So now let's scan the problem. Can we combine any like terms? On the left side, I don't have any like terms. On the right side, I notice here that I have a 6x and a negative 1x. We can blend those since we're on the side. Combine them. 6x minus 1x gives us 5x. Bring down that plus 2 that we didn't touch yet. The equals, and bring down your 18. Now remember, the goal is to get the 5x by itself. So to make that happen, we need to move the 2 away from the 5x by doing the opposite. The opposite of adding 2 is subtracting 2. And what I do to one side, I must do to the other side. And in this case, I get 16 equals 5x. Okay? Now the last step here is always going to be to divide by your coefficient, and what you do to one side you must perform to the other, and we have a fractional answer which is totally acceptable. So our answer is x equals 16/5. Thank you, and tune in to the next time.